Hi everyone, and welcome. If you've ever typed out a select star from query, then you've got the basics of SQL down. But what happens when the questions you need to answer get a lot more complicated? Well, today we're going to move way beyond those simple lookups and really unlock the power of SQL for some serious analysis. Okay, let's dive in. You know, all that data you have, it is just packed with answers. But the really valuable insights, the ones that actually drive big decisions, you're not going to find those with a simple one-line query. Nope. They require tools that can connect different pieces of the puzzle, add them all up, and perform analysis in multiple steps. So, picture this. Your manager comes over and asks you, "Hey, can you find the most popular actors among our top 100 highest spending customers?" Now, that sounds like a totally reasonable business question, right? But here's the thing, you just can't solve it with a single basic select statement. The answer is scattered across a bunch of different tables, and we need a real strategy to piece it all together. So here's our game plan. First, we'll talk about why this is a tricky problem. Then, we're going to build our SQL toolkit one piece at a time, with joins, aggregates, and subqueries. After that, we'll combine all our new tools to finally solve that challenge. And then we'll wrap up by looking at the powerful new analytics toolbox you'll have at your disposal. So, why is a question that sounds pretty straightforward so hard to answer with a simple query? Well, it's not a bug, it's a feature. It all comes down to how relational databases are designed for efficiency, which means organizing data to avoid a ton of repetition. Yeah, instead of one giant, messy spreadsheet where everything is repeated over and over, the information is kept in these neat, separate little boxes. You know, customer info is in one place, all their payments are in another, the movies they rented in a third, and so on. This keeps everything super clean and organized, but it does mean our first job is to figure out how to connect the dots between all these different boxes. And the way we connect those dots, well, that's where our first and maybe most important tool comes in, the join clause. Honestly, this is the glue that lets us assemble a complete picture from all those scattered pieces of information. So how does a join work? It's actually pretty simple. It matches rows between tables using a column they have in common. We link what's called a primary key in one table, that's a column where every single value is unique, like a customer_ID, to a foreign key in another table. And that foreign key basically just acts like a signpost pointing right back to the original table. Okay, so let's take a look at the customer table. See that customer ID column? That is our primary key. Just notice how every value is totally unique. There's only one customer with ID 1, that's Mary Smith, one with ID 2, and on and on. This is the unique tag for every single customer. Now check out the payment table. See that customer ID column again? Right here? It's a foreign key. It's pointing directly back to the customer table. It's telling us that those first two payments, the ones for $2.99 and $0.99, they were both made by customer number 1. That's our link. So how do we actually use that link? Well, we write a join clause, just like this one. Now, I know the syntax can look a little intimidating at first, but it's really just a simple set of instructions. We're telling the database to start from the customer table, then inner join it to the payment table. And here's the crucial part. We tell it how to connect them on the condition that the customer ID from both tables matches up perfectly. And boom! Look at the result. The database creates this brand new temporary table, we call it a result set, that combines the columns we wanted. So now you can see Mary Smith's name right there next to each one of her payments. We've successfully connected the who with the what. Pretty cool, right? Okay, so we've connected our data. That's a huge step. But remember our challenge? We need to find the highest spending customers, which means we need to start calculating some totals. We don't want a long list of every single payment. We need summaries. And the tool for that job is the group by clause. You can literally think of it as creating buckets for your data. If we say group by customer ID, the database puts all of Mary Smith's payments into one bucket, all of Patricia Johnson's into another, and so on for every customer. Then, we can do calculations on each of those buckets. And this right here, this is where the magic happens. On the left, you've got the raw data from our join. On the right is the result after we group it. Group by creates the buckets for each customer, and then an aggregate function like sum does the math on everything inside that bucket. It takes a bunch of messy rows and collapses them into one single meaningful summary. So how do we do the math on those buckets? We use what are called aggregate functions. To get the total spending for our customers, we'd use sum amount. If we wanted to know how many movies they rented, we'd use count. These are basically the calculators built right into our SQL toolkit. Okay, we are almost there. We have one last super powerful tool to add to our collection. See, our challenge isn't just one step, it's a two-parter. First, we have to find the top 100 customers, and then we have to find their favorite actors. That kind of multi-step logic, that calls for a subquery. And this really gets at a core idea in SQL that's so powerful. A query doesn't just have to use the permanent tables in your database. We can actually write one query that creates a result and then use that temporary result as the input for another query. It's kind of like a little production line for data analysis. So here's how it plays out. It's like a two-act show. First, the inner query, the one inside the parentheses, runs. It does its job and generates a temporary list. In our case, a list of the top 100 customer IDs. Then, the second act begins. The outer query runs, and it uses that list to filter its own results, basically saying, hey, only show me stuff for the customers who are in this specific list. All right, the moment of truth. We've got our three essential tools ready to go. Joins to connect everything, group by to summarize it all, and subqueries to handle our multi-step logic. Now, let's see how they all come together to finally solve this thing. Okay, now don't get overwhelmed by the code here. We're not going to dissect every single word, but now that we've learned the pieces, you can actually see how it all fits together. The main query selects the actor's name and account. You can see it joins all the tables we need from customer all the way down to actor. And then look at the where clause. It filters for customer IDs that are in the result of our subquery. That's the part in parentheses. That inner query is what finds our top 100 big spenders. And finally, we group by the actor's name to get our counts. See? Each tool has its job, and they all work together beautifully. So let's just take a step back for a second and appreciate the amazing toolbox you've just built. This isn't just about solving this one specific problem. It's about giving you a framework for answering countless complex questions. These are your three pillars of intermediate SQL. Joins let you build that complete 360-degree view of your data. Group by and aggregates let you boil all that data down into meaningful insights. And subqueries, they let you perform sophisticated, layered analysis that's just impossible any other way. And that's the crazy part. It really just boils down to these three core ideas. Once you master this framework, connecting, summarizing, and then layering your analysis, that's what elevates you from someone who just pulls data to someone who can truly analyze it and uncover the stories hidden inside. So you now have the framework to go so much further than just simple selections. You can find your most profitable products, your most engaged users, your most effective marketing channels. The logic is all the same. So think about the data you work with every day. What's the first complex question you're going to go ask it?